So let's jump right in. Google Web Toolkit is all about making AJAX programming easier. So first, let's talk about AJAX programming itself and why AJAX is a beneficial architecture for web applications. So traditionally, web browsers are treated like HTML dumb terminals. Every user action causes an entire page refresh. The browser itself is not capable of remembering anything across user actions. So it's like a dumb terminal. Every single thing is an HTTP round trip across the internet, which is slow and kind of clunky, and it creates a history entry, which is can be a bad thing for usability, which I'll get to in a second. But most importantly, it creates this really like slow and like really super sluggish experience when you want to get something done, and it's just frustrating, and it doesn't have to be like that. Your browser is a lot more capable than that. That's what AJAX is about. Some other usability problems that are the traditional HTML applications suffer from that AJAX can solve. The don't use your browser's back buttons. In the case of wizards, this is a real website. I removed the names to protect the innocent, or guilty, or whatever. But it's a multi-step wizard in a financial transaction, and it says just don't use your back button. Well, for a typical user, what should I do? What if I do click back? Does that invalidate my application? Does it blow something up? Does it charge my bank account? I just don't know, and it's a bad situation to leave users in. That comes because every single HTTP request creates a browser history entry. So in this multi-step wizard, you have all this weird state where you're forward in steps, but you actually can have history entries that don't correspond with the previous button and so on. Anyway, AJAX makes the browser a lot smarter because you can run code and you can actually do more sophisticated stuff. So in theory, AJAX should be able to make the browser smart enough to do better wizards than that. Another one that everybody has seen and probably does not like is the don't press submit twice or we'll charge your credit card twice. Well, what if the network hangs? What if the browser just spins? I mean, can I press refresh or am I going to buy this twice? Or even worse, like what if I really did want to buy it? What if it's a Nintendo Wii or something and I want to be sure that it comes by Christmas and I'm not sure if it actually went through or not? The little globe just spins and I have no idea what to do. That is a bad situation, and that's something that can also be solved by AJAX in theory. Aside from these usability concerns, there's the sort of shift in architecture. When you move your more stateful interaction to the client side inside the browser, this is what we end up with. I'll draw a little picture here. So traditionally, as I said before, every user action goes to the server. The server does a whole bunch of processing, spits out a brand new page. The browser re-renders it in a dumb way. That puts a lot of pressure on the server. You can see the server here is really exhausted because since the client itself is dumb, the server has to be smart and retain session state on behalf of the client. What that means is you need to pair one particular browser with one particular server, the one that's remembering its session state for it. So that means the load balancer on your server infrastructure can't necessarily send each request to whichever server is free. It has to send a request from a browser to the particular server that's maintaining state for that particular client. And that's not good from a scalability standpoint. In the AJAX architecture, you actually can do much more sophisticated things. Whoops, you can handle events locally. So if I expand a tree item, it expands right there without having to do a round trip and so on. You communicate in the background using remote procedure calls, so you fetch data, but you're able to update the UI in place. I assume you guys know most of this stuff already, but I just wanted to point out the scalability, that you get both scalability improvements because your state is now in your client. So the heavy lifting in the server can be done in a stateless fashion. So that means the client makes RPC calls to the server, the load balancer sends those calls to whichever server is free, and you can just add more servers and get more throughput. That is a good kind of architecture. Not to mention, in addition to using your IT resources better, you get the real-time interaction that a user would expect. So I click on something, something changes like immediately. Here's what happens with AJAX. Everybody has their development process down pat. They're using struts or JSP or something like that. That's a Java shop. We've got this under control. But then we want to add a little bit of scripts to do some kind of cool feature. Everybody loves it. Maybe I'm going to get a promotion. Who knows? I'm the new AJAX guru at our company now. Let's do more of this. The next thing is the salespeople start selling features that you're not even sure you know how to implement in AJAX, but they're really excited about this AJAX stuff, and it helps them make sales. So all of a sudden, you are an AJAX shop against your will, potentially. Then, about 6 months later, they want to sell into an organization that won't run Internet Explorer. Say for security reasons, they want to run Firefox. So then you begin to understand what makes AJAX actually really hard. This wonderful code base that works so well in Internet Explorer does not work at all in Firefox and so on. And you can imagine as you try to support more browsers, how this can become really hard. In fact, only once you do this can you fear browsers with all of your mind, body, and spirit, as you will if you ever try to do a very sophisticated AJAX application imported to all these different browsers. And of course, at the end, you're forced to quit your job because you've created this mountain of spaghetti JavaScript that nobody could possibly be expected to maintain. Besides, you're an AJAX guru now. Put that on your resume and go get your next high-paying job. But the point really is, seriously, that when you're writing this code, one way or another, you're making an investment in AJAX. You're creating a code base that you're going to live with for a long time. You either are creating a good code base or maybe a not so good code base. Either way, you're doing an investment. Let's make sure it's a good investment. So Google Web Toolkit is a way to build these sorts of applications with Java technology rather than manually with JavaScript. GWT is interesting because you actually develop everything in the Java language using Java tools, and then you cross-compile to JavaScript, to a standalone JavaScript application that you can deploy to browsers. It's different than Applets because it doesn't require a Java virtual machine within the browser. And so what I described is essentially a compiler, a Java to JavaScript compiler. But there's really a lot more to it. This particular technique allows a lot of cool innovations that we'll talk about in a few minutes. So now let's switch over to this same source code Joel's going to show you if we switch over to the demo computer.
So this is basically your typical Hello World application. It looks, to any Java programmer, it looks fairly familiar. Instead of main, we have an entry point interface, but otherwise pretty straightforward. We've got, let's see what do we have. We've got a button, click listener, anonymous init class, some stuff that looks sort of like JavaScript if you're familiar with that, window.alert here, but all straight up in Java. So I'm going to run this just like I would any other Java application, except what's coming up here is what we call a hosted browser. This, to clear up any confusion, this is not entirely obvious. This is actually a real browser. I'm running the wrong app. That is actually an embedded version of Safari in this particular case because I'm running, or WebKit, because I'm running on a Mac. And here we're going to see the app. Now this app isn't terribly interesting, but when I click it, you'll see that my window.alert pops up. Okay, not too exciting yet. It's at a slight bit more of excitement, so I'm going to set a breakpoint. Now anyone who's done a lot of AJAX is already kind of surprised by this, I suspect, because you don't usually set breakpoints in AJAX apps because the debugging tools are terrible. So now we're back in the Java IDE. And you'll see I've got my breakpoints, I've got expression watches, I've got variables, I've got my call stack, all the stuff you would expect and would normally have in any Java IDE.
You should show Cinder what happens when you
So
click
we've
on
got Cinder here. This is the button that actually sent that event. And here we have, in this particular case, it's toString. For those familiar with Java, is overridden such that it renders the HTML that would basically show you the structure of that widget. So basically, just like this was Java native, except that essentially it's a browser under the hood. So I'm going to continue here. Same dialogue, no big surprises. Now, one thing that a lot of people say, realistically or reasonably, I think, when they first see this idea is, well, this is great, but I really don't want this complex Java compile, type, compile, debug cycle. I like just editing my code and hitting refresh in the browser. And there's really no good reason you can't do that here. So what I'm going to do here is apply a very simple refactoring, which, by the way, this is one of the major benefits of using Java tools, is you get whatever you have in your IDE, whatever it may be, Clips, NetBeans, IntelliJ, what have you, all those tools are still applicable. So things like refactoring, this is a very simple one. We're going to refactor a constant string. You'll now see it's up here. I'm going to change the language for fun. Save. Refresh. Now when that refreshes, I still have a breakpoint. Now the language has changed. That string has taken effect. I didn't actually pay attention to the fact whether it's being compiled under the hood or not. In fact, even if the IDE is not recompiling automatically, it still will refresh just like it would in normal web development. So we like to say all the power of your Java tools, but without losing the basic model of web development.
So it'd be cool to show that actually running as JavaScript.
Yes, that's a good point. So I'm going to hit this compile browse button. Now this is basically what this is doing in the background is compiling down to JavaScript. What you saw before was running inside the virtual machine. Now it's actually running inside the browser. So now this is running in Safari, same application. Simple application, but it kind of shows the round trip here. And you can view source on this and see that there is actually almost no source to speak of. It's all tucked away. But that's the basic process.
Very nice. So if we'll switch back over to the slides now. All right, so what we like to say is that we look at GWT as a way of bringing software engineering practices to the AJAX world. So you can use any Java IDE. It's not an Eclipse plugin or anything like that. It's designed to work with sort of the natural JVM in the way that it works. It's sort of a library on steroids under the hood. You don't even have to use an IDE at all. So you get all the rapid edit, test, debug cycle that you would expect from any sort of Java environment. You get unit testing. There's direct support, integration with JUnit. You get reuse through jars, which is a fantastic way to prevent mistakes and build up libraries of your own code. You can build frameworks the same way that you would with Swing. You can build your own Java frameworks in-house, or there are third-party frameworks that you can reuse that are open source and so on. You can take advantage of real OO design patterns, things like all the Gang of Four patterns, the visitor pattern, and builder pattern, all these sorts of cool MVC, sort of patterns like that. The things that you've come to love about Java architectures, and you can actually replicate those within your client-side browser code. You get things like JavaDoc, which is an area where traditionally it's really hard to do thorough documentation in a JavaScript code base. It's really easy in Java, so that's another benefit you get sort of automatically. And probably the most underestimated one is that you actually get compile time errors. So if you make a mistake, if you mistype a field or method name, that is actually a compile time error. It's the kind of thing you don't miss until it's gone. If you've ever debugged a large JavaScript code base and found out you made a typo on line 5,937, you don't find that out till later when you try to reference it by its right name. Then there's a spelling bug, and that sort of thing does not scale well to team development. GWT helps you avoid those sorts of situations. So this slide, by the way, is kind of what you were showing earlier, how you could just change your Java source and refresh, and it works as easily as if you were writing JavaScript by hand. So now take a step back, talk about the GWT mission. So even though it is very technical, it's a compiler, it's Java-oriented and all that, the actual mission of GWT is to help people make web apps that are great for users. We want end users to visit the web and see that there are better applications than there would have been without GWT. It does that in a couple ways, but the basic philosophy is users first, developers second. We want it to be as easy to develop as possible so long as the results are great for users. Like we would not consider adding features to GWT that are really fun for developers or interesting or even super easy at the expense of the end user experience. Things like just GWiz technology, just doing fancy, spinny, sexy-looking things just because is not really something that we're particularly focused on. So if you look at the GWT widget set, out of the box, it's actually kind of bland looking. We assume that that's not what's really most important. You'll style things in the way that's best for your users. So we focus our energy on making the applications really fast and really small and so on. If you share this perspective, GWT is something you might want to check out. So you want to talk to web usability a little bit more?
Yeah, so a really important thing to note is you'll see a lot of AJAX frameworks, if you will, out there, frameworks, tools, what have you, that try to bring the desktop to the web as if that were what people actually want. We don't actually believe that users want that. The users actually want the web, they just want it to not be slow and sluggish and awkward. So to that end, in GWT, we really focus on getting the basics right, but the basics in the world of the web, not the world of the traditional desktop application. It should work like any other web page works, just better. The UI, we don't reinvent every UI element. We make new ones where we absolutely have to. For example, there's no native tree widget on the web, so we create one of those. But the button should be native, the text box should be native. There should be no surprising behaviors that don't fit the traditional model people are used to, other than optimizations and so forth. Things like, for usability and accessibility, font size. My parents, for example, need larger font size. If they change the font size, the layout shouldn't go screwy on you. And that seems pretty obvious, but it is something that actually very often goes wrong. The keyboard use is another big thing, both for accessibility, but also for people who have gotten used to using the keyboard and have gotten very fast at it. They should be able to tab between controls normally. They should be able to, if they focus a tree control or a list box or something, it should just work.
You can imagine working with customers. If you're on the phone doing tech support with a customer working against a web app, you don't have time to grab the mouse and start clicking on stuff.
Exactly.
It needs to be good, fast throughput.
Then on top of that, speed. Fast, we're fond of saying, fast is in fact better than slow. And you'll notice that, if you ever do any research on the subject, you'll find that abandonment rates of websites go up very, very drastically and non-linearly with time. And that time is on the order of hundreds of milliseconds. So the difference between a web app that starts up in 300 milliseconds and one that starts up in 900 is a lot of lost users. That's important, and again, it's something that's very easy. If you write a lot of JavaScript code, if you're not careful, it's very easy to let that get slow. Sometimes it just kind of gets away from you. So we focus wherever possible. We can't make it automatic, but we can give you the tools to make sure that your app does in fact start fast. So a really, really important aspect of this is really along the same lines as history. One of the things that really characterizes a browser as being different than most traditional applications on the desktop, that's changing these days, but generally still the case, is support for the browser's history. Now, we've actually all gotten used to history not working. As Bruce pointed out earlier in some of these examples, a lot of the time, don't hit the back button, things will blow up. Hit the back button and it says, there is post data, do you really want to send that again? All these things can go wrong, even in traditional web apps, but in AJAX apps, it usually just doesn't work at all. Like you hit back and you leave the app. No matter what state you're in, no matter what you're doing, hit the back button, game over, you're out of it. Some applications do a fairly good job of dealing with this, but most don't. And it's a really hard problem, that's the reason. The browser, there is no native AJAX support in the browsers themselves for dealing with history programmatically. But in GWT, we've gone to great lengths, excruciating lengths, I might say, even, for anyone who's ever tried this, to make it free, to make it simple and straightforward. So you'll see here, it's as a programmer in any traditional object-oriented language, you would expect to see something like this. Add a listener, let me know when history changes. I need to make a new history item that is a new stack frame, if you will. And the end result should actually be reflected in the browser's location bar. So you'll see we've overloaded, this is becoming sort of a standard, if you will. We've overloaded the hash part of the URL to refer to internal application state, which is relatively philosophically, I think, compatible with the traditional use for anchors. But the beauty of that is it looks especially to a naive user, just like any other URL. Here's a place. Here's the information encoding my state. I'm in this place within this application or within this site, and they can just create links to them. Works just fine. As long as your application deals with the events properly, then you get bookmarkability, so we like to call it, for free, as a function of, or as a side effect of implementing history correctly. So internationalization, this is another big deal, and kind of another part of sort of the Wild West of AJAX applications. There's a lot of different ways people approach this, mostly ad hoc. GWT really provides two ways of approaching it, but this is actually my favorite. To take a step back for a moment, this is really part of the core philosophy of the framework, of the toolkit, is bring static type checking wherever possible. compile time checks to the table whenever possible. So in this case, you'll see we define an interface for the message, in this case, like it's essentially a string table. You'll see the middle section here in green, there is a message that is to be replaced with a localized version, and with template arguments for replacement. Then at the bottom you see an application of that. So messages access denied, and it's passing 2 arguments here. As the bottom line says, this actually wouldn't compile because the access denied message has 3 template parameters. Well, then there are only 2 things being passed in. And this is really important because this is the sort of thing you usually only find out at runtime. And the whole philosophy of the system and kind of where we started from was we're tired of finding out about things on user machines, tired of finding out about them at runtime, tired of seeing error dialogues pop up at runtime or bizarre messages or what have you. So this is another instance where we try to hoist compile time checking and take advantage of that as much as humanly possible.
Especially on big apps where you've got like one team that does the localizations and another team that does the code. It's really easy to have mismatches between the message templates where there's like 3 placeholders in this example, and the people writing code, they might supply 2 arguments or 4 arguments or whatever. It's nice to be able to find that stuff at compile time.
Exactly. So CSS, this is another thing that we believe is really important and is becoming more and more prevalent on the web. People are really taking advantage of it, and it's great for styling, skinning, if you will, under some circumstances. So we don't throw that out. Wherever possible, this is sort of speaks to what we like to refer to as the web native nature of GWT. All the widgets get styles. Styles can be applied in style sheets, which are included in the traditional method. And that actually also saves you a lot of code because you don't have to do all of your styling in code. Why invent a new way to do styling, to change fonts, to change colors, all that sort of thing, when there's already a perfectly good one there? So we adopt that in GWT as well.
And yeah, like internationalization, if you had a different group that was sort of writing code from the group that's doing styling, you can easily separate out those tasks, and the style people can manipulate the CSS style sheets, and the coders don't have to worry about it.
Right.
So now some demos. We promised
okay,
demos.
We did promise demos. So if we can switch screens one more time. So this is what we refer to normally as the kitchen sink. You'll see here it's running in Firefox, and this basically is just a playground for trying out all the widgets that are in the system by default. So you've got some various tabs here. And there's the sort of things you would normally expect. You have buttons and customized buttons, menus, cascading menus, that sort of thing. We do layout via panels. This is sort of like Swing or AWT, or SWT for that matter. You've got draggable splitters, tab panels, lots of images, just various ways for organizing your widgets on the page without too much overhead or work. List boxes, combo boxes, suggest box is one we've just put in 1.4. This is like you've seen this in Google Suggest or in Gmail when you type in your addresses or what have you. This is built in as a framework so that you can back it up via server data if you need to. You can back it up via data on the client side. However you want to do it, it's pretty straightforward to build.
And it's cool. I just saw you using the keyboard to navigate that list.
Oh yeah, it's very important that. Again, this is probably can't see my fingers, but we've tried to again get keyboard support as deep as humanly possible. Same thing goes for trees. So we have trees. Again, I'm doing this entirely with the keyboard. These things are all built in by default. We tried to build in the harder widgets to build by default so that you can then compose them into whatever structures you need. This also goes for rich text, which is one of the more nightmarish widgets to build in practice.
Joel's asked to be lobotomized after having implemented the rich text widget in GWT. He said once it ships, rip all this information out of my brain.
I really don't want to know ever again. It's really, really quite horrible. We just shipped this. So after getting through that process, the rich text was by far the worst thing I've ever had to build. pop-ups, dialog boxes, these kinds of things you would expect normally. This, by the way, is one of our other team members brandishing a lightsaber in front of President Carter at our open house, which was enormously fun. The part you don't see is him being beaten up by the Secret Service, but that, it was worth it, he says.
He still finished up his compiler enhancements for 1.4 though, so that's,
exactly.
That's what matters.
They didn't break his fingers, most importantly. So one thing that you've not seen in this, but I've been doing all along, is each pane in this application is in fact a new history item. Let's see if I can get that visible in the URL bar. So you'll see right now it says, if you can read that at all, it says pop-ups at the end. This is again in the hash part of the URL. Now if I hit the back button now, it's going to take me back where I just was. You'll notice this also changed. Hit the back button again, go back all through where we were. This is, and forward as well. Sometimes people get the back button right, but then forward is a nightmare. If you have a good structure for dealing with this, then it all becomes relatively for free. What we can also do is, because that is affecting the URL bar as we go, I can create a link to it. So I've created a link to the list section. I'm going to back up. This will take me back there. That's nice. Convenient. If I send a link to someone, as long as they have access to that application, they can link to it just like any other normal application, except it's just faster. Also, something that often fails if you're not very careful. So let's just go to some other site. I'm going to go to About because I don't actually have an internet connection right now. And I back in. Now, most oftentimes in AJAX apps, this just fails. It just takes you back to the beginning or does something bizarre. But again, if you just use the built-in functionality, then it'll back you right to exactly where you were. As long as your application can reconstitute its state from the state information that it has in the URL bar, you're good to go. So, and that goes ad infinitum. So if I go back into, let's say go back to lists here, forward a bit, back a bit, back a bit, back a bit. You can sandwich that state as much as you need to. So it behaves, again, this shouldn't be surprising to a web user. It behaves as it is supposed to behave, as users will expect it to behave, except that you get a chance to intercept these events and make sure that if there's any uncertainty as what should happen naturally, you can program around it. You can make the stir of the state make sense at any given point in time. Another thing about this application that's worth noting is that it was, I'm not going to go into the code right now, but it was built using essentially a simple but effective client-side model view controller structure. So the details of that aren't so important, but what's really important to note about it is that it makes it really easy to say lazily construct the individual panes. So these panes are all available, and as I'm going back and forth between them right now, they're not being reconstructed because they've already been constructed. So it keeps the application fast while it's running. But you don't want to construct them all up front, because if you did, then the application startup time would be really slow. I mean, whether this particular one would be or not, with a certain number, it would start to become slow. So these are the kinds of structural things that we enable, that Java enables for you relatively easily, that make it easy to optimize where you need to optimize. You optimize at a high level rather than trying to tweak every individual little bit and sort of peephole optimizations. You can create a structure that naturally runs fast, naturally does only the work that it needs to.
I like to say when you have better tools, you have more confidence in trying something that's more complex, that's better for the users.
Right, and you don't spend your time thinking about the quirks and the details, just trying to get it to work. Mm-hmm. You spend your time thinking about the high-level structure that allows you to do the right thing. So another demo.
Well, actually, I think it'd be interesting to show the startup time because of the way you lazily create the UI parts. It helps you start up really fast. So you show the one thing that gets constructed at startup, but then you kind of amortize out the rest of the speed as the user uses the app.
Right, so I'm going to refresh here. Now this is that startup time. I just slipped this in this morning. It's measuring the time from the very first bit of HTML, so basically the script tag at the very top of the outer HTML document, to the end of the entry point. And so by the time it reaches the end of the entry point, the UI has been constructed and the UI is visible to the user. So that's 229 milliseconds. That's not too bad. I'd like it to be faster than that, honestly, but it's not too bad. Now if I go to, say, Safari, which happens to be a bit faster, so that was 235 milliseconds uncached. Go back to it again, and it hangs up, which really isn't showing us much of anything useful. Okay, well that was odd. Okay, it's a little under 200. That's a little better.
And also, before you leave this app, I think it would be cool to show to change the subject, it would be cool to show the font size thing too.
Oh, good idea.
We talked about font resizing and how it's hard to...
Let's just ignore that. I've got something really strange going on with my... oh, you know what? I think I may have a proxy setting wrong or something on that. Let's... all right. That's good. I'm glad that no one else has these problems with demos because... let me... Really quick, this is slightly embarrassing, but I'm just going to make sure that this is... that I have no weird proxies set up. Okay. Anyway, so this is, as Bruce points out, as we were talking about before, font size changes are something that usually cause complex layouts to fail or do odd things. So if we go to, what's a good example, like panels, change the font size, it should just work, right? So as I get these gigantic fonts for my blind grandmother, it really shouldn't be a problem. But that, again, is something that's very easy for that to go wrong.
And even there's some subtle points, like the choice of panels, the choice of layouts that are part of GWT. Actually, those are kind of, we made those decisions because those are the kinds of structures that do scale automatically when you resize. So there's a lot of thought that we put into those sort of little subtle decisions that you can benefit from just by using it. And it's actually kind of easy to use too.
Right. And sometimes that actually leads us to not do things that people request or that people want to do because they cannot, in some cases, just because of the technology that exists in browsers currently, they cannot be done in a way that will actually satisfy all of these constraints. They'll be fast. They won't blow up on resizing. They won't have problems with font sizes, so forth and so on. So we try to maintain all these constraints as much as humanly possible so that no one gets surprised or no aspect of what we're trying to enable here starts failing surprisingly because no one's checked font resizing, for example, in the new crazy tab widget we create. I'd also like to show, this is an example of, if you do want to create apps that look like roughly like desktop apps, you can still do so. It's not verboten at all.
But the goal is that it would not be any less functional. You wouldn't add bling just because you can. You would add the functionality that really helps users.
Right. Okay. So this is, make this a little bigger, sort of a traditional Outlook style mail application. You'll notice that it, rather than rolling off the bottom like a normal web application, it's resizing rather to fit the screen, which for some applications that's appropriate. So you have a sub area that's scrollable. You can imagine all the various bits and pieces. Nice and quick, I think. Got various little WYSI widgets. These are not hard to create at all. Pop-ups and so forth. And still the keyboard support in the tree. Again, important little details you just don't think about. You just put the tree in there, go, and it will do the right thing. Now, I'm going to run this. Again, back to the compile browse button. Excuse me, Safari is badly misbehaving. Okay, there we go. That's more like it. Now this is the same app running in Safari. This really is fast, I promise. It is really, really fast.
So yeah, it could be like a network hiccup or something, but I was hoping we could actually show this live if your machine wasn't barfing. But this morning we kind of had a holy crap moment because this mail demo, and you can try this out yourself if you download the 1.4RC.
Yeah.
What were the startup times you were seeing?
It was sub 200 millisecond startup time. So granted, that's off of localhost, but still, a lot of the time, you find yourself in complex AJAX apps, you find yourself doing more time or spending more time executing JavaScript than anything else. And the fact that we've gone to a lot of trouble to get the startup sequence really, really quick. And
yeah, in fact, so I want to talk about one last thing on this, and then we want to show you some of the particular measurements and improvements that we've made in GWT and how it'll affect you. But to go back to that for just 1 second,
oh, sure.
Or do you have it handy?
Sorry, yeah.
This uses a feature that we have in GWT 1.4. We just did a release candidate yesterday, the day before yesterday. there's a thing called image bundle. And so traditionally in AJAX applications, or even in HTML, you spend a lot of your time requesting little images. And most of the time, those images haven't even changed, but you still use up HTTP connections at startup, which there's a lot of contention for because there's only 2 outgoing connections in the browser and so on. So what image bundle does is it lets you really easily, in Java code, specify all the different images that you want to use for that application. And then at compile time, there's this code generator that actually takes all those images. This is compile time. It takes those images, combines them into one image strip, and replaces the place in the code where you're using the images with a reference to a clipped sprite out of the image strip. So this, for example, has, I don't know, maybe 30 different individual images.
Give or take.
Using image bundle, this requests exactly one real image over HTTP. And so what you're seeing is really just little clipped images onto the larger image.
So Firefox is not misbehaving right now.
Okay.
Give you an idea. So I just hit refresh. Let's do it again. Here, I'll select a different email so we can see it change. Okay, ready, go. Now, one of the things, that was a refresh, which means normally that will send, on almost any application, that will at least send last modified requests for each image on your app, which, as Bruce was saying, you eat up both of your HTTP requests that way because you only get 2 at a time. Everything else is serialized on that. So, and those HTTP requests create the TCP connection, send the headers, get the response, close down tear down the connection, move on to the next one. That takes a lot of time. It's actually very, very significant. Moving that all down to one image and then setting up the headers explicitly so that you know it can be cached forever. Because of the way the image bundle is constructed, it's created with a strong name, we call it, or basically a hash of the content hash. So you know you can just set the headers to expire when the sun explodes.
And so when people at first, like we launched this a year ago, GWT, and so at first people were saying, oh, compiling Java to JavaScript, that's weird. From now on, we'll say image bundle. Like that's you couldn't do it if you couldn't create something like image bundle if you weren't compiling and analyzing the source code. So and there's a lot more of those sorts of things in GWT and a lot more that are coming down the pipe. What I'd like to do is switch back now to the slides and kind of show you over the last year what we've done with GWT. And pretty much all these things just happen automatically. You just write code like you want to, and you benefit from the optimizations that we do. So for example, there is no minimum size GWT app, really. It's a function of the code that you write. In this particular graph, I started with a blank application, and then I started building it up. I added one widget, then another, then another. The compiler is smart, and it can analyze all of your code. So as you add a little bit of code, it reuses what's already there, and it strips out methods that you don't call, it strips out classes that you don't instantiate, and so on. And it does really smart analysis. So what you find is that the application gets bigger only really as a function of how much code you write, which has some pretty nice effects as you trend towards writing larger applications. Also, using the AJAX architecture, and in particular, GWT has a really strong RPC mechanism that lets you send Java objects back and forth across the wire. You can get really nice bandwidth usage as well. So the red line shows a traditional application that's identical to the one we wrote with GWT. And then the green line shows the first run of GWT as I do multiple requests. The reason it's high up, it's like 45K or so, is that you fetch the script once, the compiled script. When you refresh, it's already cached locally, so it requires almost no bits to be sent across the network. And then as you move through the application, you have a very, very small slope because you're only sending little bits of data over RPC in the background.
One thing, if I can add about that slide, is that this is a subtle point, but we often think for modem users, of which there are still, I don't know, about half the people in the country, that having a big chunk of JavaScript to download would be a negative thing. But actually, the end result is better. I've tried this on my parents' machine. They live outside of the DSL zone back in Atlanta. And the mail sample, or a few other samples that I tried out, so it takes 5 seconds the first time it hit on this one particular app that I tried, but then it was extremely fast. Whereas normally, because of that large slope on the red line, every page loads a little bit faster, but each one is equally slow to the last. But once you get an app up, it it is blazing fast because you're sending these tiny little packets over the wire. And actually, the RPC mechanism, this is, without going into too much detail here, is even tighter and more compact than you would get with, say, XML or something like that, because both the server and the client are in Java, they are compiled together. They can agree on the format of the messages, so you can drop all the metadata. It's as compact as can possibly be. So there's a lot of little things like that that can make a big difference in the actual speed and user experience.
We talked about HTTP traffic. So last year, this is, I think, the mail sample. That sample did something like 23 requests, HTTP requests at startup. The same application simply recompiled with GWT 1.4 now does about 7. And so that has a huge effect on your time to start up. Not only are you sending fewer bytes across the wire, you're making fewer socket connections in the first place.
To be fair, that does involve reconstructing an image bundle,
yeah.
But that was about 5 minutes of work.
Right. And then we talked about what the compiler does, but also when we do compiler size optimizations, you simply recompile. A typical application with 1.4 is maybe 15% smaller, 20% smaller. You don't change your code, you just recompile, which is pretty nice. If you had a JavaScript app you wrote by hand and you needed to make it smaller, it would be hard to know where to start. Right. RPC is another thing. If you use the GWT RPC mechanism, we can just make it faster, and all you do is upgrade, and your app just gets faster. So that's another really huge benefit. And this shows what we've done over the past year to make RPC much faster. This is for 50 calls, 50 round trips.
I think we should give Sam a little shout out here on this one.
Yep. We had this guy say, hey, if you change this one line of code, this was when GWT was partially open source. You change this one line of code, you can speed up RPC by 1,500%. So I was like, okay, good suggestion. We did that. And by the way, of course, could you send a resume? He's like, I'd love to, but I actually have to go to college next year. But he is our intern this summer.
He's here
somewhere. Here today.
So Sam, if you're out there.
Yay. All right, so there's not nearly enough time to demo everything. There's unit tests, there's benchmarking, internationalization. You can include external CSS and JavaScript. There's this thing called deferred binding that does dependency injection and code generation, which is what Image Bundle uses, RPC uses, internationalization does all this stuff through code generation. Everything is cross-browser, although you only saw WebKit and Firefox today. We also support Internet Explorer 6 and 7 and Firefox on Windows and Linux and what are some other ones? Oh, and Opera as well. Even on the Nintendo Wii, you can run GWT apps. You can actually develop on the platform of your choice. So hosted mode, the debugging environment works on OS X, Linux, and Windows. And you can use, as I said, any IDE that you want. GWT is fully open source. As of this past December, all of it's open source. We do our development in the public. There's like 8,000 plus members of our user support group, which is a great place to go to get started with GWT. And then over 300 contributors have already committed code and have contributed by either suggesting ideas or contributing code and so on. A bunch of patches made it into 1.4, in fact. So even though it's open source, we decided to document it. So you'll find that hopefully the doc will help you out, and if it doesn't, the user forum is really thriving. So in the past year, we've done a whole bunch of stuff. We've seen IDE support, direct IDE support for GWT in IDEA, Eclipse, NetBeans, and other products. We've seen major applications that have been developed with GWT already, both internally at Google and externally. Tons of external libraries as well, third-party libraries. If you do a search on Google Code for GWT, you'll see over 100 projects and so on. And I'm happy to say just a couple of weeks ago, we surpassed 1 million downloads, and we're really happy about that. Lots of features in 1.4. If you check out the GWT blog, you'll see all the new features in a blog post from 2 days ago. It kind of enumerates the same stuff, and you can get a feel for whether or not you would find this stuff useful and you want to try it out. So anyway, to wrap things up, we think you can really use leverage to take advantage of AJAX without introducing a lot of risk for yourself. You don't have to hire PhDs in browser quirks anymore. You can hire good Java developers, and they can use GWT to build the next big thing. Probably most importantly, if you're doing good engineering practices, GWT will reward you. Rather than writing JavaScript by hand, it kind of tends to reward you being willing to do all sorts of insane hacks. We tried to change the equation with GWT. Anyway, it's all open source. We'll continue to share our very best work and ideas with you guys. We hope you'll join us online and participate in the fun. Thanks very much. We were going to do Q&A, but I think we sort of ran out of time, right? For 3 minutes? Yeah, okay, actually, So we do have just a couple of minutes to do Q&A. If anybody does have any questions, please bring it on.
So I have two. I am I'm not a PhD in it, but I'm definitely the browser quirks guy, and I'd love to code myself out of a job. The two things that give me reservation are integration with existing Java apps and also customization of the controls you guys have built with GWT. So if I have a if I have a Spring MVC app, how easy is it to make it play nice with GWT? And if I want to use crafty HTML buttons, how easy is it to make GWT generate them rather than the native form controls, things like that?
Right. So a couple of important things to note. One, we bend over backwards to make sure that you can interact with your existing, both your client-side JavaScript and HTML code, wherever appropriate, and also existing Java code on the server. Now, if you're talking about porting an existing MVC, say Swing app or SWT app or something, there's going to be engineering work involved there. It's really not the same library. There are frameworks that try to do that sort of thing, and the end result usually is less than pleasant, just because it's just not the same world. We're not really in Kansas anymore. So we don't want to try and hide you from things that are going to turn around and bite you later. On the front of interacting with using all the browser quirks, taking advantage of all these things, there is still a lot to be gained from that kind of hackery, and we don't want to make it impossible. We don't want to even make it hard, because it is actually necessary in the browser still, and we have a fair amount of it ourselves. What's important to note, I think, is that we didn't get a chance to show this, but you can write inline JavaScript inside your Java code. Just check the doc, you'll see, or just go looking through the source code.
Come to the fireside chat at 3:30.
Do that too, yeah. And B, I guess the way to look at it is we allow you to do all the hackery you want, but then you get to wrap it up in a class and hide it in a black box from the outside world, or as black as it needs to be, so that it doesn't have a bunch of loose dangling wires to trap people up later. But it's still absolutely possible, and we do it all the time.
Take your AJAX foo and wrap it up and let other people use it who don't share the foo. Next.
Okay, how much do you guys collaborate with the Google Gears so that we can use the same features? Do you collaborate a lot on that?
Yeah, actually, in fact, just yesterday, last night, we announced that there is a new project that's GWT API library for Google APIs. So the first one that we're supporting is Gears. So if you already use GWT, you can go download the Gears API bindings right now. There's like I forgot what it's called, but it's a jar. You just add it to your class path, and you can start programming for Gears immediately.
And how do you guys scale for non-JavaScript enabled browsers?
How do we scale for non-JavaScript enabled browsers?
How do you do links? If you have a pane and you have tabs, will the tabs open up a new page with the proper information, or is it just
all the stuff you saw in this particular case was all JavaScript. So it's JavaScript running, driving the DOM. So if you need to support non-JavaScript enabled browsers, typically we would say use the NoScript tag and actually present just a different simplified HTML UI. We can talk about the specifics more in the fireside
There
chat.
is actually more of a middle ground, but we could, if you come join us there, we can talk about it in more detail.
And we probably won't be able to get to all the questions. I'd say the same thing. If you would like to come to the fireside chat, we'll have time to talk about this stuff in a little more depth.
By the fire.
By the fire. Do we have time for one last one? No, sorry. Very last one. We'll catch you outside.
Join us.
All right. Thanks again.
Thank you.